The overall goal of convergent polishing is to polish a glass workpiece from a ground surface to its final polished shape with excellent surface quality, regardless of its initial surface shape, in just one iteration. This is achieved with the implementation of a polisher using technologies to reduce the complexities associated with traditional polishing. An important step for convergent polishing involves preparing a workpiece-specific septum weight for the polisher, which compensates for pad wear and allows for more uniform temperature and slurry distribution. Next, the polishing is done under a fixed set of parameters in order to achieve convergence to the final desired surface figure through a natural pressure renormalization process. The results show that 265 mm square ground glass workpieces repeatedly achieve a 330 nanometer peak-to-valley surface figure in one 4-hour polishing iteration.
The main advantage of conversion polishing over existing methods, like full aperture conventional polishing, is that the workpiece achieves excellent surface figure and quality under a fixed set of polishing parameters in one iteration, leading to a faster, lower-cost finishing process. In contrast, conventional full-aperture polishing methods require multiple iterative cycles of polishing, metrology, and process changes by a skilled optician.
Convergent polishing is only made possible by the reduction of the inherent complexities of conventional polishing, as shown in the illustration in all the boxes, from this to this, involving the use of technologies that remove the spatial inhomogeneities of material removal of the different mechanisms.
In addition, rogue particles are prevented from entering the polishing system, and any created during the polishing process are actively removed. This leads to little or no scratching and low roughness surfaces.
This protocol involves use of the scissor convergent polisher to achieve a flat, polished surface with a peak-to-valley measurement of 330 nanometers and a low scratch density. The polisher has a granite lap base that is covered with a polyurethane polishing pad with a thickness of 50 mil. A principal feature of the polisher is the job-specific septum weight, which has a different shape and weight depending on both the workpiece and lap sizes. The workpiece for this demonstration is a 265 by 265 by 8 cubic millimeter fused silica glass flat. The polishing pad should be conditioned before its first use and after every 100 hours or so of polishing. To do this, employ a 50 mm round diamond fixed abrasive chemical mechanical polishing, or CMP, conditioner taped to a weight. The weight provides 0.6 pounds per square inch pressure and fits into the ring mount of the polisher. Start the flow of deionized water and rotate the lap at 25 RPM. After every 5 minutes of conditioning in one location, move the conditioner radially by 25 millimeters. After conditioning and removal of the conditioning apparatus, the pad is ready to be cleaned with an ultrasonic cleaner. Have the lap rotate at 5 RPM with deionized water flowing. Apply the ultrasonic cleaner for 2 minutes at each radial location to remove residual slurry and glass products. After cleaning the pad, turn attention to the custom septum weight for the workpiece. The septum weight and a matching piece of septum material will be affixed to one another. To do this, adhere double-sided foam tape to the surface of the weight. Trim any overhanging foam tape to match the shape of the material and weight. When the surface is covered, align the weight and the septum material and affix them. Next, Prepare the polishing slurry of cerium dioxide and deionized water to Baume 4 concentration in an 11-liter bucket. To adjust the pH to 9.5, add approximately 5 drops of 10 molar potassium hydroxide. Also add about 120 milliliters of surfactant. Check the Baume concentration using a Baume float. With the desired slurry installed into the filtration system, check that the filtration system has the desired CMP particle filters. Then start circulation of the slurry in the system and let it continue for several hours. When the slurry has circulated for a while, collect a sample from the slurry tank for analysis. Make a measurement of the particle size distribution, for instance with this single particle optical sensing instrument. The distribution should show that the tail end of the distribution is free of larger particles. Here, the green data points are representative of the slurry used for this protocol. Preparation of the workpiece begins with etching. Using a quantity of buffered oxide etch sufficient to cover the piece, immerse the workpiece in the etch and keep it there for 6 hours to remove 10 micrometers from the surface. After recovering the workpiece from the etch tank, rinse it vigorously with deionized water. Allow the piece to air dry vertically. If the piece passes inspection, proceed to get ready for blocking by preheating an oven to 70 degrees Celsius. Meanwhile, in a glue gun, heat blocking pitch to 95 degrees Celsius for application to the blocking plate from the polisher. When ready, follow a pre-planned pattern to place droplets of blocking pitch onto its face. For this demonstration, the droplets should form a 9x9 array with 26 mm spacing. With the droplets made and facing up, place the blocking plate in the 70 degrees Celsius oven. Now, work with the workpiece to apply tape to the face that is not to be polished. When applying the tape, avoid generating air bubbles or stretching the tape. When taping is complete, the workpiece is ready to be affixed to the blocking plate that has been retrieved from the oven. Place it tape side down onto the droplets on the blocking plate. Place the assembly in the oven for 1.5 hours at 70 degrees Celsius. Then have it cool at 10 degrees Celsius per hour to room temperature. Then cover the assembly to minimize convective flow. At the polisher, turn on the humidity system in the environmental chamber to prevent the slurry from drying. Next, install and mount the prepared septum weight into the polisher. Once the blocked workpiece is at room temperature, install it into the polisher and lower the boom to hold it in place. Start the slurry flow from the filtration system at a rate of 1 gallon per minute. Polish the workpiece using a rotation rate of 25 RPM and a radial stroke of 75 millimeters. Continue this for 4 hours. At the end of 4 hours, have ready a bath of deionized water sufficient to submerge the workpiece assembly. With the lap motion and slurry flow off, remove the workpiece assembly from the polisher. Take it to the deionized water and immerse it. While it is submerged, wipe the workpiece surface with cleanroom cloth. Remove the blocked assembly from the bath and spray rinse with deionized water. The next step is to deblock the workpiece. Be careful of the polished surface and use a shim for deblocking by inserting it at the workpiece block interface to separate the two pieces. Once it has been separated, remove the tape from the workpiece surface and vigorously rinse the workpiece with deionized water. Before continuing, allow the workpiece to air dry vertically. Meanwhile, prepare to repeat the blocking and polishing steps to deal with the other side of the workpiece. When both sides have been polished, mount the workpiece on an interferometer for characterization. Measure the reflected and transmitted wavefront on both sides of the workpiece. After the interferometer, mount the workpiece on a bright light inspection station. Measure the scratch dig properties using optical fabrication standard methods. After characterization, store the completed workpiece in a container that minimizes contact with the polished surfaces. Here is the final output of the Convergent polishing protocol for the square workpiece. A better sense of what has taken place is provided by these typical initial and final surface figures for 265 mm square fused silica flats. PVQ is the peak to valley surface height after 1% of the high and low data points have been discounted. The process reproducibility converges workpieces to the same final surface figure without requiring changes to polishing parameters and is independent of the initial surface figure. Here are additional before and after surface figures generated from both round and square workpieces. The Convergent polishing protocol can be used with workpieces of various glass compositions, shapes, sizes, and final surface figures.
It is important to remember that this relatively simple procedure is only possible due to the numerous technologies allowing for convergence to work and allowing for high surface quality. These include a novel shape septum, bulk acid etching, pitch button blocking, radial stroke, hermetically sealed high humidity polishing chamber, engineered filtration system, novel chemical slurry stabilization, and in situ ultrasonic pad treatment.
Once mastered, Convergent polishing can finish an optic surface in 4 hours. That's an entire workpiece in a single 8-hour shift. We can finish flats, spheres, symmetric A-spheres of different shapes and sizes, and different glass compositions.